Welcome back students, and we were studying about the first chapter of class 9, that is number system. And inside the number system, in the last class we have seen rationalization. Rationalization, as we have seen there, is the rationalizing of the irrational numbers. If we are given root 3 and we multiply it by root 3, it becomes 3. If it is in the denominator, we multiply root 3 by root 3 and we get root 3 as numerator and 3 as denominator, and we have this converted this denominator into a rational number, that is 3. So this is what we had studied in the last class. Today we will study about surds and rationalizing factor, and then after we will see some of the questions of rationalization. Surds. See, real numbers a real number can be expressed as a rational number or an irrational number. Surds comes under irrational numbers. Irrational numbers are of two types: root 2, root 3, root 5, cube root of 7, cube root of 9, fifth root of 11. These all are irrational numbers of one kind, and another kind, pi, is also an irrational number. The symbol e, it has some value, it is also an irrational number. So this type of irrational number is called surds. These are surds. So what do we come to know, or what conclusion we draw here? That every irrational number is not a surd. There are irrational numbers that are not surds, but every surd is an irrational number. So this is about the surds. Clear up to this? Now if we have a positive number inside a root, is it a surd? Is it compulsorily a surd? No, it is not true. If you have 4, its value will be 2, which is a rational number. And surds comes under the irrational numbers. So this 4 square root of 4 is not a surd. If it is root 3, yes, it is obviously a surd, because we have a positive rational number inside a root, and this number is not a rational number. Thus you see if you have an irrational number and when it is a root of positive rational number, then it is a surd. And all the irrational numbers are not surds, but all surds are irrational numbers. So the first topic, surds, is clear to you. Since we have started about the surds, I think you must know about certain things, just a little for your knowledge. If we have like this, and here it is n, and there is some positive rational number, and this number is irrational. So here there are three elements. One is n, another is a square root, this root symbol, and then a. So there are these three things. This n is called the order. What is the order of this surd n? This symbol is the radical. Here, and this A is radicand or base. So if I ask you fifth root of 11, what is the order here? Order is 5. This symbol is radical, and this 11 is radicand or base. After this topic rationalization, we will move towards the laws of exponents, where you will come to know that since you have already studied about the laws of exponents in your earlier classes, you must be knowing that this can be written as 11 1 by 5. When you have any number in the form m by n, so this is the base, this is what exponent, and when exponent is expressed in the form of m by n, then n is the root, nth root it is talking about. So if it is 1 by 5, so it is fifth root of 11. If we talk about 1 by 3, then it is cube root of 2. Okay. What does this minus sign represent? If I say minus 1 represents the reciprocal of this number. Okay. So this is just for helping you to re-memorize whatever you have studied in your earlier classes, because what we are going to study next will be related to this. Our topic will be laws of exponents. So we have studied about the surds. This much of information about the surds is enough for this class. Now rationalizing factors. If I say you have root 3 and you have to rationalize means to convert it into a rational number. So how can you convert this root 3 into a rational number? You can convert it in various ways, or multiplying it by various numbers. Suppose we have root 3, then you can multiply it by root 3 and you will get, the root will be removed and it will be 3 out of the root. So this 3 is a rational number. So what we have done? We have done rationalization, because we have converted an irrational number. We have converted this irrational number into a rational number, and which number has helped us? This number. So this is the rationalizing factor. Again, if you have root 3, if you multiply it by root 3, you will get 2 into 3, that is 6. Again a rational number. So root 3 is what again? A rationalizing factor of 2 root 3. If you see here, 2 root 3 multiplied by root 3 gives a rational number, That also means this root 3, when root 3 is multiplied by this 2 root 3, it will also give a rational number which is 6. So can we say root 3 is a rationalizing factor of 2 root 3, and 2 root 3 is also a rationalizing factor of root 3, because they both are helping each other to get converted into a rational number. Three root 5, it can be converted to a rational number using root 5. So root 5 is helping this 3 root 5 to get converted into a rational number 15. So root 5 is a rationalizing factor of 3 root 5, and we can also say 3 root 5 is a rationalizing factor of root 5, because 3 root 5 is also helping this root 5 to get it converted into a rational number. So these are rationalizing factor of each other. These are the rationalizing factors of each other. And rationalizing factors are also sometimes called conjugates. Rationalizing factors are also sometimes called conjugates. Let us take 2 root 2. How will you rationalize it? By multiplying by root 2, it will be 2 into 2 equals to 4. But is this the only way to convert this 2 root 2 into a rational number? No. You can multiply 2 root 2 with 2 root 2. Here you will get 2 to the 4 into 2, 8. You can multiply this number, this given number 2 root 2 by 3 root 2. This will give you 2, 3 is 6, and this 2 will come out of its root and get multiplied. 2, 3 is 6, and 2, 12. 2 root 2 multiplied by 4 root 2. You will get 2, 4 is 8, 8, 3 is 24. So you can see there are a lot of numbers. There are infinite numbers that can multiply this with this 2 root 2 and get it converted into a rational number, or rationalize it, you can say. So this 2 root 2 has infinite number of rationalizing factors. So any number can have an infinite number of rationalizing factors. Remember, I am saying can have. So this is about the rationalizing factors or conjugates. I hope it is clear to you.